Good morning and good afternoon. My name is Stefano Lind. I'm the head of marketing for InfoSec Global. Would like to welcome you for this webinar around cryptographic inventory, delivering value today and preparing for tomorrow. I hope everybody can hear us fine and we have solved all the technical issues that we were facing. So let me get started with introductions. Today we have Leon Malkanovsky from HSBC with us and Blair Ganawan from Thales. Leon, would you like to go ahead, please?
Hello, yes, good morning, good evening, good afternoon, wherever you are. My name is Leon Malkanovsky. I work in HSBC and I am currently focusing on cryptographic agility and the inventory initiatives within the bank. Other than that, I did my master's in quantum electronics. I worked in multiple domains, Industry 4.0, blockchain, telecommunications, look forward to this conversation.
Thanks a lot, Leon. Blair?
Hey, good morning, good afternoon, good evening, Leon, Stefano. I'm so glad to be with you today. We've been talking about this for a long time and really excited to be here. For those who don't know me or haven't been on one of my Bright Talks in the past, I've done quite a few in this area of quantum and post-quantum cryptography. My background goes back to a long time ago with companies like Symantec and being the first employee here in Canada, and then quickly into the cryptographic industry with startup companies like Chrysalis, who is and still is the origin of the Luna HSM product back in the mid-90s. So I'm now at Thales running our post-quantum portfolio and alliances, and been working with all of you over the last several years on this topic. This has been a long time coming, and I can't wait to share and hear from both of you on what we're doing here. So looking forward to it.
Perfect. Thanks a lot, Blair. For the audience, we'll take questions. This is meant to be an interactive session. We have a few slides just to set up the topic, but feel free to submit your questions in the chat box as well, and we'll try to answer them as they come in, or before or after later on in the session. First, we would like to actually get to know you as well, and we have a few poll questions ready to go for you. So, do you associate yourself with cryptography? Yes or no? Do you represent financial services institution? And last but not least, do you actually have a team that is focused on PQC transition at your organization?
Stefan, I see the slide, but I don't see the poll. Is it how it should work so that the attendees, they have a poll they can respond?
Yeah, they have the poll on the right-hand side of their screen. And people are answering.
Oh, okay.
This is the beauty of going live on these things.
Yeah.
We learn as we go.
So far we have over 80% of people that actually do associate themselves with cryptography. So a very technical audience. We have about 15 answers so far. Okay.
It sounds like you have whales in the background at your location, Stefano.
Yes. Oh, it's mine? No, it's not me.
That's maybe my somebody is drilling next door. So that's sorry about that.
Sometimes these things happen.
So first question, we have 84% of the people actually do associate themselves with cryptography. We have a third of the people in the chat in the session today are representing financial services institution, and actually half the organization, a little bit less than half, 45% of the organizations that are represented here today have actually a team focusing on a PQC transition. So that gives you an idea of what the audience is.
Excellent.
Well, that's a brilliant audience, because that means we can really have very nice conversation today.
Yes, indeed. So you want to take over the slides and do some setting the scene, Leon? Oh, wait, we have one more. We had one more. With one more poll.
Yeah, we'll give that just a minute or two.
Yes.
That was
Well, maybe you want to talk about this the first slide.
Yeah, go ahead, Leon.
Well, no, go before. Yeah, the one. Yeah.
The one before.
Yep. Yeah, this is the one.
Yep.
Blair, you want me to speak up, or maybe you will do it?
Well, you start, and I'll add in just what I can.
Okay. So, anyways, this is a very nice image, and I wonder if many people in the audience really had seen it before. And that is a rhetoric question, what it is. But the answer is it's a quantum computer. And because we'll talk about a cryptographic inventory and migration to post-quantum safety, naturally a lot depends on when such a quantum computer will appear, and specifically a quantum computer that will be able to break the current cryptography, PKI in particular. So, Stefano, I don't know if you ran that poll, which we had just seen a second ago. Yeah, this one.
So yeah, 94% of the people believe that a quantum computer will be capable of breaking today's cryptography.
Awesome.
So
okay.
Vast majority.
That's a big change, Leon. I think that all three of us over the years have heard varying levels of skepticism as to whether or not there would be a cryptographically relevant quantum computer. I don't think we're having that argument anymore. It's not a question of if, it's a question of when. And I think you can shed some considerable light on that discussion today.
Yes, and that's where the next slide actually gives us a little bit of insights into the timeline. So this report was produced by the Quantum Risk Institute, and it shows responses from experts in the field who think when such a quantum computer will be created. And given the context and the answers to the poll right now, I think let's look at the numbers. Like, for example, in 5 years' time, respondents believe that the probability that such a computer will exist is between 5 and 14%. And if we take an average, say 10%, then let's pause for a second and think about what that will mean if a quantum computer capable of breaking public key infrastructure will exist with that probability of 10%. Is it a big deal or not a big deal? And then there are several analogies out there in the world about how we can sense that number. I like using an analogy of a car, and then if somebody has a very nice car and they drive it, and then there is 10 probability that it will explode or something happens to it, and will we still want to drive such a car? And I know, Blair, you have your analogy of your own as well.
Yeah, I think that a lot of us have been in this long enough to know that regardless of any technology, whether it be a plane in the sky, a car on the road, a train, any type of transportation, using the latest avionics, using the latest maritime technology, it's the same with an electric car. You wouldn't dare push an AM radio into a brand new vehicle, an EV. So we're all moving at a breakneck pace, and we have to realize that we're accepting the latest and greatest, and do not underestimate human evolution and certainly technological progress. So I think this is what's most telling to the audience, is that we're having a reasonable conversation about something that's not yet appeared on the horizon, but the indicators and some of the progress made is definitively proving out our theory, and so on and so forth. So anyway, I'm really excited.
And then if we take that as an input, we assume that in 5 years, there is 10% probability that there will be something, a big event. Then we probably would like to prepare for that eventuality. And this is where we also, posing ourselves the same question, decided to think about the first step in this journey, which is cryptographic inventory, and from which angle we tackle this challenge. And a couple of years ago, when we were deliberating how to approach this mammoth challenge, we thought, okay, perhaps it's not only us who will have such questions, but the wider audience. And we came up with this idea to write down a white paper with some thoughts and insights about it. Do we have that poll, Stefano, for the audience about who has read it or not?
Yeah, we should have that. Let me see. No,
Leon,
we don't.
And Leon, I think it's an opportunity here to do a little recollection for us with regards to how this started. And when I say that, how did this cryptographic inventory conversation even start? This was a conversation that you and I had in November of 2023. This goes back just a little while, but the essence of that was a friendly conversation about what HSBC was doing. And perhaps that lends a little bit of context to our conversation, which was, you knew that you had all these cryptographic assets. You understood that you had to move to this next paradigm of compute. But when we left the conversation, it was clear that the introduction to InfoSec Global's AgileSec was paramount here. And I'm very, very proud of that conversation, because we, instead of talking the talk, you started immediately to walk the walk. And I think that bears in this conversation today, is you have to get started. So I'm going to let you continue, but I just wanted to highlight that moment, that's how long it takes sometimes to get things started.
But an interesting, thank you, Blair, for reminding that. But there is an interesting aspect to this story, that it is not simply a transaction.
Right.
It's a journey, and it's a collective journey. It's an ecosystem which is critical to the success, because different stakeholders in the ecosystem, they have different capabilities, and they can contribute to this overall success. So I think what was good about that conversation and the experience afterwards, that we collectively, they were willing to share knowledge and collaborate together. And that is the spirit I think we should carry forward.
Absolutely. And everybody has a stake in this. And I think that's bearing part of this conversation, is whether it be Thales, but all the ecosystem of vendors that you support, the vendor community. You knew and we knew that this is going to take a lot of people collaborating, coming together. A lot of that is lost on some of the audience, that you assume it's just a technology you apply here and the result is a solution. This is not that at all. There's a people, what is it, to people, process, technology, or whatever the term of reference is. But we understand that it takes a lot of synergies between these organizations to get this going. So
And from that angle, the role InfoSec Global now plays and Keyfactor in setting up, for example, this event is also very useful and interesting and important, because what would be nice is actually for the audience to contribute, to share their opinions, their experiences, and ask questions, so that we can learn from the audience as well.
Indeed. So on that point, no, we have no questions yet. I hope that the audience will actually submit some of their questions. But should we actually talk a little bit about the definitions of what cryptographic infrastructure even is?
Sure, let's do that. So I guess one of the key messages is that cryptography became an important critical asset infrastructure piece, and it underpins digital models, digital economy, digital society, and digital trust. And organizations depend more and more on digital interactions. And that's why what we do with the cryptographic inventory carries paramount importance to deliver that ultimate outcome for modern businesses and for the modern society. And maybe one thing to start with is the evolution of cryptography, because initially it used to be only confidentiality, authentication, and integrity. And so many, like 20, 30 years ago, say, for example, in the United States and North America, there was a standard for mobile communication AMPs, and it did not encrypt the telephone conversations, so anybody could take a scanner and listen to some telephone calls. And then, naturally, at some point in time, confidentiality was enforced and created with the GSM standards. Now we can talk about adding to this list of capabilities non-repudiation, availability. So much depends on availability of digital assets. Say a computer doesn't boot if something is damaged in TPM, or network session is not set up because the parties do not agree on the protocol, or a certificate server is down and nobody can connect to the system. So availability became very relevant. And then validation, and coming together with that, trust. How do we trust a system? Is it because we authenticate and authorize access to the system? Can we, again, ensure that a transaction has been done by a trusted entity? And we can talk about the use of cryptography a lot, but let's move to the slide about the cryptographic inventory itself. We were debating this definition for some months, and this is what we came up with. And each word actually carries a lot of weight and a meaning. So what we say, it's a dynamic piece, and that means it changes all the time. It's not like we do it once and we relax. No, it's comprehensive. We would like to reach to as many systems as possible and to understand what cryptography exists in them. It's systematic. There are some rules. There is automation there. Current and evolving. So it's not only one-off, it's what was in the past, what might be, or how we want it to be in the future. Instances, it's not only the configuration parameter or an inbuilt capability in the software component, it's also a replica or an instance of it. And then extended digital infrastructure, not only what is within the perimeter of an organization, but also suppliers and third parties. Naturally, cloud providers play a big role. We would like to know what cryptography is used there. And then the aim is to provide a unified, detailed view of when and how these objects are deployed, they're consumed, and how they're governed. And therefore, the questions that we would like to answer And then, by the way, yeah, if in the audience anybody has questions, feel free to jump in, or I don't know if there is comments ability there.
Yes, we had one question from Christoph Brötter from Ernst & Young about if that includes actually all cryptographic components that are included in software as well as hardware solution, and if those can be identified and then obviously documented and inventoried. And that obviously must include symmetric as well as asymmetric keys, certificates, tokens, libraries, et cetera, et cetera, et cetera.
So ideally, yes, although naturally it's not that easy, and there are black boxes, there are systems which are offline, for example, industrial controllers, they can be air gapped. There are some systems with high level of protection, and simply only a small number of users can access those systems. So therefore, the level of coverage depends on use cases, priorities, business priorities. And we talk about it later on in the white paper about what to prioritize, how to prioritize, and how to achieve that balance between trying to scan everything versus getting some tangible outcome with scanning some assets rather than all assets. But that's a valid point.
It's a great question. Let me jump in on a couple of things that you're going to talk a little bit about, and we certainly in the white paper expand on this topic. This is an evolving process, and that's a fair statement, that as we move into this realm of a robust cryptographic inventory discovery and monitoring and visibility tool set, I think it's really bears mention that depending on whether it's software or hardware, some of this is going to be proactive, and some of this is going to be reactive, and some of it's going to be automated, and some of it's going to be manual. And I think that we're learning in real time that, for example, vendors like Thales, or vendors in the load balancing or any type of hardware device or software device will provide information to this inventory tool from an automated point of view. This is evolving. And for example, it will spit out metadata. As opposed to actually reaching into an HSM, which is a no-no. We're going to provide metadata. We're going to provide information that is readily available for the housekeeping, if you will, for the cryptographic hygiene. So I think that'd be really interesting as we go through this conversation today about what this white paper explains is we've already taken a big chunk out of it in today, and as it evolves, it's going to get even better.
And sorry, go on.
No, I was just adding to you started a comment about machines, IoT devices, and all those things. Obviously, they will have to be included in this discussion as well. Although we're talking about financial services, we had an interesting conversation with the manufacturer and the other company the other day that had CMC machines, and they want to produce some fairly sophisticated and sensitive elements. And the question was, do you actually have an inventory of the cryptography included in the CMC machine? Because they want to make sure that machine is safe as well. I never thought of it that way, but it's definitely a component. And obviously, cryptography is really everywhere, no matter how big or how small the device is. And it's therefore critical that we know what is actually available, not just in the software, in the hardware, as Blair said as well.
And this is where these questions become relevant, because when we start to answer these questions, what cryptography have I got? Where is it located? Is it in a server? Is it on a remote device? Is it in an IoT device? And then what purpose that cryptography serves, whether it's fit for purpose, and that depends on the type of assets and the classification of the value of those assets, what level of confidence we have in deploying and using that cryptography. And that ultimately leads us to some decisions as to where do I start and what I prioritize. And again, it's difficult to make such decisions if we don't have visibility into cryptography and assets that use that cryptography or are protected by that cryptography.
I have another question, Leon, that I would like to bring in at this point. Once you have the completed inventory, do you have to redo it? Is that something that you do periodically? Is it a once and done thing? How do you guys think about that?
So it's not going to be static, that's for sure. But the speed of updates and the level of dynamics in an inventory depends on the type of a system and the corresponding requirements. So first of all, the speed of, or rather the frequency of scanning or updates depends on the target system. If a system is static, for example, there is an application, the source code is frozen and it does not change, generally speaking, we don't need to scan that repository GitHub again because it didn't change. However, if it changes, then naturally we would like to know what the change is and whether there is any impact on the cryptography. So we can do it, that trigger can work automatically. It can be a configuration parameter. If there is a change in GitHub, let's do it, scan it again. And then some of other systems, they can be dynamic, like containers. They come up and down, or critical systems, which are real time. Then we may want to know what happens and what cryptography is used there, if not real time, but quite frequently. So ultimately, it is live, but the frequency of updates depends on the type of an asset and the life cycle of an asset, and also it should be a configured parameter in the inventory system. I hope that answered the question.
Yes, thank you.
Okay, shall we move on? And then perhaps as well, relevant to the previous question, because it also depends on what cryptography we talk about. Operational cryptography means something which is embedded in some systems. For example, an operating system. A Windows or Linux machine, there is a lot of cryptography there, and we may want to know what cryptography is used, how it's configured. Software cryptography, we develop software, be it our own software or purchase software, and then it goes on top of an operating system. And also, naturally, there'll be a lot of cryptography network connecting different systems together, network routers, firewalls, and other appliances. That falls into that category. Managed cryptography, be it internally managed or externally managed. It can be PKI servers, TAs, or cloud providers giving some cryptography, and that may be managed by a third party. And then hardware, again, we spoke about it briefly, IoT devices or TPMs or HSMs. And as you would appreciate, there is a lot of variety in all those categories. And also that creates another challenge. How do we connect and gather cryptography from those diverse systems? Did I miss anything, Blair?
No, that's spot on. I think, and we want to emphasize, and the white paper does describe this in detail, not all of this is at your fingertips. And why? Well, because we didn't build out or integrate. We've woven so much cryptography into everything we do and have that it wasn't built to be extracted easily. It wasn't built to be found easily. Why would you? It works. It's not broken. And we want to remind people that current cryptography standards like RSA and ECC are fundamentally unbreakable. So again, if we look back and we could do it all over again, we would have made these things easily found and easily more modular and things like. But now what we're finding is that a combination of being able to find it from an automated tool set like ISG's AgileSec is great, but there's going to be some lifting and maybe some heavy lifting to find and determine where in fact you have it. Case in point is we're going to find out things that we didn't anticipate. Some things are going to be good. Some things are going to not so good. We're going to find out, for example, we haven't been following cryptographic policies that we put in place 10 years ago, or we said we were going to deprecate an application, whether it be a banking application or an application that we interact with another organization. These are the things that we're going to find out in real time. And that's the real challenge is once you have all that information and visibility, it's up to the organization to determine what those priorities are. And I know, Leon, you have a lot of priorities on your plate. So I'm sure you can share a little detail on where do I start? What's my priorities and how do I get there?
Before Leon, you answer the question, I have a question from the audience for you, Blair. It's a Thales customers, and they depend on Thales HSMs for their daily activities, obviously. So the question is, when we say cryptographic inventory, does it mean the symmetric, asymmetric key backups, exports, or simply the list of keys in the system?
Great question. I'll take a stab at that and I'll get clarification. So the quick answer is that it's all keys. But again, what we expose from an HSM point of view is limited in terms of metadata. So for example, as I said earlier, the way that you interact with an HSM through an application is through a standard PKCS11 interface. And it's a major no-no for anybody to have access to an HSM through that interface. Those are limited to applications and by security administrators. So what we're doing right now is we're providing metadata. So we're literally going to say it's an RSA key with this length or with this algorithm or with this. Again, that metadata is all we're going to expose from an HSM point of view. The same thing goes for our use of keys within, say, an encryption platform, such as, say, CipherTrust or anything else. We have a REST API, which would allow you to go in and find out that key information. That's where InfoSec Global simply reaches in and pulls that information about CipherTrust. So there's 2 or 3 different ways we can do this. Going forward, you're going to see a much more robust REST-based capability for most HSMs that they'll just literally provide that information at will. But we're crawl, walk, running right now, and we're evolving. But the good news is that HSBC is not limited to just one little bit of information. They get the full breadth of information on the HSMs.
And that actually leads us to perhaps the next slide about the challenges. And before we talk about how to actually resolve that situation, maybe we'll briefly speak about why this is difficult. So heterogeneous sources. So there are so many types, even like if you talk about HSMs,
right?
There are actually multiple vendors. Is there one industry standard to collaborate between them? I don't think so.
You'd think so.
Well, I mean, there is PKCS11, but there is a lot beyond PKCS11, which is in HSMs. Yeah.
And there's by design reasons why you hide not necessarily the asset, but the actual cryptographic details or attributes. So I think that what we're seeing here is that's no longer the case going forward. That, as I said, as long as you expose it without exposing access or the ability to manipulate those HSMs, we and all the other vendors that we interoperate with, and that goes for the Thales, Unimaco, Entrust, Enshield. All of us are unanimous in our approach that we want to provide that cryptographic information for tools such as AgileSec.
Awesome. Yeah. So, and I think hopefully there'll be more and more collaboration between various industry players so that the life of end users becomes easier.
Yeah, and the word heterogeneous is not lost on you, especially when we talked about this years ago. And many organizations, they have many HSMs. I've talked to one large bank that they have, believe it or not, 14 different HSM vendors. And I said, I didn't even know there were 14 HSMs. So we're learning in real time that you're going to find things and be surprised what you'll uncover.
Yes, the next one, third-party dependencies. I think we'll go bullet points. Yeah. So third-party dependencies are relevant to the previous point, but it's wider because we depend on, again, cloud providers, telecommunication services, cybersecurity providers, government services, etc. And then I know that one big entity in Europe, they said, we are going forward with this post-quantum migration, but it seems our partners or customers, they move at a different speed. And that means, like, do we waste our time and effort if others do not catch up with us? Do we need to wait for them, or we need to push them? Yeah, an interesting dilemma.
If I can jump in on that one in particular, what we do see is a trend, which has changed. So, for example, 5, 6, 7 years ago, when I started talking about quantum, most people crossed their arms, leaned back, and said, "This is somebody else's problem." 5 years from now. Well, now it's 5 years from then. And I think what we're seeing is a trend towards, I wouldn't say unanimous, but the majority of organizations that most companies rely on, let's call it the core partnerships that they have from a vendor community, are all unanimously supporting post-quantum migration. In fact, it's a differentiation point that if you ask any vendor what the cryptographic posture management is and they don't know an answer, or you mention what they're doing from a PQC roadmap point of view and they don't have an answer, you have your answer as to whether or not that vendor is moving at a reasonable pace. We being managing well over hundreds and hundreds of technical integrations, I will assure you that the majority, well over 80% of the companies we deal with, have a PQC plan for their product line. So that's encouraging, and I want to share that with everybody.
Yeah, and it's mandated, well, not mandated, but recommended. There are some advisory notes issued by various regulators in the world. So there is definitely certain push. Insufficient classical tools. A common question: why don't we use, say, vulnerability management or threat intelligence platform or code scanning tools to extract cryptography and create inventories? And the answer is that they're not simply designed and optimized for that purpose. While they do have some cryptography-related information in them or in their outputs, it's often a small portion of the total output, and it becomes sometimes difficult to extract those pieces, as well as to analyze and contextualize them. So therefore, while they should be used and the information in those tools should definitely be consumed and synchronized, it's very difficult to rely only on those tools to create that cryptographic inventory. Large-scale dynamic environments, I think we spoke enough about that. Sensitive data, it's not only the data which can exist in the target systems, but also cryptographic inventory itself also generates data which is very sensitive. So getting access to sensitive data as well as generating sensitive data puts certain requirements and overhead on the process. Need for automation, because of diversity and the scale, it's virtually impossible to do that manually, right? Unless it's a one-man organization. But automation tools, they just they're new, and they don't always work as intended. They have blind spots. For example, they cannot scan black boxes sometimes. They need to have access rights to scan a target system of sort. Therefore, it's not a panacea, and it will have to be complemented by manual intervention. which naturally requires deep subject matter expertise, not only at the gap analysis, but also just to interpret the data collected by those automation tools. And then the last bit about regulation, because there is no universal global standard for cryptography. In various jurisdictions, there are different laws, and therefore being able to comply with those multiple requirements is not trivial either.
And I'll say to your point on the regulation side, without regulation, we do have advisory capabilities from the likes of the Deloitte's, Accentures, KPMG's, Kyndryl's, Capgemini's, IBM's. All of them are also unanimous that they're providing guidance to say, listen, in lieu of having a compliance audit, or in lieu of having a standard regulation for cryptographic inventory or cryptographic usage, what they're doing is they're helping organizations tool up for this, and in the process, they're setting in place really a framework for regulation. So I think best practices really adheres here, and we're seeing this with large entities all over the planet that are seeking guidance from those organizations. As I said at the beginning, this takes a village. You can't do it alone, but you can certainly reach out and seek advice from those organizations.
Yes. Stefan, should we move on, or are there questions?
Hold on. I have a quick question about the compliance. Obviously, we work with a lot of big global companies. Obviously, HSBC is one of them as well. And you mentioned the jurisdictions, different restrictions, different compliance regulation, maybe different internal policies with organizations as well. How is a big organization managing that complexity of having maybe different compliance requirements in North America versus Europe versus Asia? How, ultimately at the global level, do I enforce the most restrictive policy top down for everybody, or how do you guys think about that?
Well, I don't think I'm the right person to answer that question, because that's a question to the compliance team. But naturally, the first step is to know and to be aware about that, and then also prioritizing compliance. And then what we in the technology space can do and simply facilitate and enable compliance. And that's where the versatility and the capabilities of technology tools and platforms, they become very important, just to help compliance teams and others, everybody in the bank, just to be compliant.
There's a good analogy here where think of the International Space Station. In order for you to dock with that space station, in order for you to travel into space and those kind of expenses, but think about it as simple as that, is in order for you to just work within that environment, you must adhere to the not only compliance, but the technical specifications. And it's the same within the financial industry, whether it be the SWIFT network, whether it be the PCI regulations. This is going to merge into those compliance specs to some degree, because it's really, in essence, an algorithm shift or an algorithm change, which we're starting to see those, of course, CNSA requirements and compliance requirements for large organizations around the world. I think you're going to see over the course of the next 12 to 24 months some pretty stringent processes put in place. So if you want to, for example, be part of the SWIFT network, again, we're the back end for that. That's 2.5 to 3 trillion a day of large value transfers going through that network. You're going to have to follow, and you're going to have to adhere to those specifications of use of crypto, et cetera, et cetera. That'll be a no-brainer. But that's really a simply put comment. I'm just saying that it is evolving, and organizations will adhere over time.
So we have about 15 minutes left, maybe a couple more slides, and then a more discussion. Unless there are questions, Stefano.
No, we addressed all the questions for the moment.
Okay, good. So one slide about the difference between cryptographic inventory and CBOM. And naturally, those in cryptography, they must have heard this acronym CBOM, Cryptography Bill of Material. And there are some major differences which actually drive some of the decisions regarding building cryptographic inventory. So one point is that CBOM focuses on inbuilt capabilities in software, and as such, it not often or never almost, it depends naturally on many other things, look into deployment scenarios. And cryptographic inventory, on the other hand, does try to identify deployed assets, configuration parameters, and various instances, because it can be one library but deployed in many different environments. Then the purpose also a little bit different. While CBOM focuses on trying to secure a software component and application, the inventory goes wider and broader, trying to identify cryptography usage configuration parameters, which is critical, again, to compliance, as well as to wider cryptographic and security posture of an organization. Then there are differences in the pace of change, how often a software piece is updated versus certificates or external connections or containers are updated. There is difference in which data is consumed by software versus other systems in the IT infrastructure. There is difference in correlation between different various assets, such as, for example, data assets and cryptography used to sign a document. So the variety of context is different between CBOM and cryptographic inventory. And then ultimately, policy enforcement, policy to software development, so DevSecOps versus organizational policy are normally often different. Did I miss anything, Blair, there?
No, spot on. I was going to say one of the things we hear all the time is the interchangeable, the assumption that CBOM and cryptographic inventory are the same thing. And we say, no, and you've explained it perfectly. And I'll also say that this is an element where often you'll have multiple points where you can triage or triangulate, I think is a better word, where you'll actually have the information or the algorithms coming from the hardware or the software or the firmware. Oftentimes you just need to have two proof points to ensure that it is in fact there. And I think this is a really a great way to explain that. Everybody understands SBOM. I think they do in source code and source code analysis, but CBOM is a broader cryptographically specific area. And I love how you've broken it, as a much broader aspect. So get your CBOM together, but it's only one part of the entire cryptographic inventory. So yeah, absolutely agree.
Cool. So we have probably 2 more slides before we wrap up. The 10 inventory principles. So again, many months of deliberation about how actually to tackle this big challenge. So first one is seek executive sponsorship, because such an initiative will likely impact the whole organization. There are so many stakeholders with different priorities and different constraints. Without executive sponsorship, it will be really difficult to progress. Scale with automation, we spoke about that. Optimize manual prioritization, again, touched upon that in the beginning. And maybe point 5 and 6 and 7. So context is critical. I had an interesting conversation recently, and the question was like, okay, we have a key. What to do with it? And I don't know. How do I know like what key it is, how it was generated, how it's used, and which system it protects? So having context is critical to understand whether that cryptographic asset is fit for purpose.
Right.
And then that leads to number 6, where ideally we would like to generate actionable insights. If it's fit for purpose, then fine, perfect, let's move on. If it's not, then we would like to perhaps update it, change an algorithm. But then who owns that algorithm? Is it the cryptography team or a third party? Who decides on the acceptable level of risk? Who knows resilience requirements? So being able to understand the landscape and create an action item is really important. And then AI can help sometimes to do that because of the large volumes of data which are likely to come into an inventory. AI can help to normalize data streams. It can help to create metadata and contextualize, enrich the data streams. It can also give some advice to
Right.
those engaged, for example, in cryptography operations or business owners, whether, for example, this specific item affects compliance or affects or there is vulnerability associated with it. So I think there is a lot to explore there with AI being so dynamic now.
And Leon, if I may, this was a wonderful aspect of this white paper talking about AI. And what I wanted to add to your point is, think of the power of when you mention the context within a key is a key is a key, and where it is and how. Just telling me I have 30 keys or 30,000 keys or certificates or certificate sprawl, key sprawl, whatever. The AI, I think, is something that we're all looking at, and it's a large portion of our business as it is with many. Is imagine distilling that information and analyzing that information, categorizing that information, and putting it in human readable formats. AgileSec has a terrific reporting capability and a terrific UI for dashboarding that. But if somebody says to you, Leon, could you just tell me what it was when we started, where we're at now, and what the percentage differences are on, for example, old crypto that's deprecated, or have we moved all of those certificates into a certificate lifecycle management platform, like, say, for example, the Keyfactor provides. Those are things that I see AI. We're experimenting right now just to look at how do we generate useful information that the executives can understand. So I'm really excited about where we're going with that particular area.
Yeah, there's a lot of potential there. And maybe point number 9, we have a special slide on that. Golden source for cryptographic inventory. And it's a dynamic trusted repository of relevant data so that users and systems can make decisions and take actions. The challenge is that there are so many systems, and we spoke briefly about that, for example, vulnerability management or static scanners. They will have some cryptography related information. HSM may have some metadata in it. So which source, and there may be some differences between them, which one do we then trust and take actions? That's not a trivial one, because one user may favor one specific source while another uses another source. So unifying those multiple sources and creating one source of truth,
right,
is really a must, but also a big challenge.
And I think that minimizing bias as well. We understand confirmation bias. A lot of people will look for problems and use the tool maybe not so well. So we want to make sure that it's scrubbed, it's validated, and to your point, that golden source or a term of reference is something that can be used within other systems. So that's another conversation for another day, is where this information can be consumed by other tools within the ecosystem on a SIM, for example, SIM tools or data security analysis tools. And there's so many more opportunities to utilize that knowledge base.
I actually equate the golden source to what we used to do when I first started out in financial services around the customer information or the master data management.
Right.
Problem with customer data, same problem. You had customer data everywhere and nobody was really clear which one was the correct record. So you needed to have the golden master for all your customer data. It was then followed by product, have a single place where you have all your products listed. And that's a term that I have used, that I've heard with customers as well, master data management for cryptography, as equating it to the golden source or similar, same concept,
right.
But in this case, it is for cryptographic data.
Right. We're just running out of time here. I'm just looking at the clock for everybody. If we could make sure we finish up here, I'll just let you continue.
Well, actually, we are almost done. I don't know if there are any questions or somebody, Blair, you want to read kind of the conclusion piece?
I think we've done this better than just aside from the technical difficulties we should have mentioned at the beginning. We apologize for that. This is what you get with live. I think we just want to leave with everybody here on the call, give in the last 30 seconds. I'll start with you, Leon. What would you suggest to leave the viewers here with today?
I think one probably piece of advice is to look critically at the cryptography, how it is used, whether it's fit for purpose, and maybe the role of cryptography should be revisited, not only as a risk minimization technology, but also potential value creation technology, and cryptographic inventory is just a tool to achieve that goal.
Excellent. Stefano.
I think my take is not underestimate the size of this problem. It's a huge problem. I think there's still a lot of organization that don't take it very seriously. They think, oh yeah, it's 5-10 years away and the priorities I have today are more important. But reality is it will take a long time for this transition. If you look at transition from SHA-1 to SHA-2, it took 5 to 10 years. And this is X time more complex than just move one algorithm to the next one. So I think the key takeaway should be, let's not underestimate that. Let's start looking at what we can do and how we can start to take care of this problem, because it will happen.
And if I don't get cut off here, I was just going to say that we should welcome this process, this emergence of technologies and best practices, because I think most organizations have shifted from theory to practice, and this is an absolutely essential, regardless of the size or scope of your organization, that you should undertake to some degree, whether you perform a biopsy or a representative analysis of your cryptography, or a full-blown MRI or complete enterprise-wide scope. This is something that you weave this into your procedures from a cyber point of view. I think that everybody here appreciates this is just emergence of technologies. We're making changes, but this will become common for all of us over time. But I just want to say thanks to all of you, and thanks for having me participate in your webinar today.
Thank you, everybody. Thank you, Stefano. Thank you, Blair, for this wonderful conversation.
Thanks, gentlemen.
Have a great day.